Hello, everybody. I am back to do a couple of problems for you from the section on solving higher degree equations. So, solve higher degree equations. Excuse my handwriting. I'm still getting used to all this technology. Okay, and so by higher degree equations, we mean x is raised to a higher power than 2. So examples that I was asked to do in particular, this is the first one. And the method that we're going to use for these for the most part is the zero product property. And just to refresh your memory, zero product property tells us if A times B equals 0, then, well, think about it. If you multiply two quantities together and you get 0, then one of those quantities must be equal to 0. So that's kind of our underlying idea for these. So we have here it's equal to 0, but we need to rewrite this left-hand side so that it is expressed as multiplication. And the way we do that is by factoring. And sometimes the zero product property is referred to as solve by factoring. So if you're ever asked to solve by factoring, you set it equal to 0 and then factor. So on this left-hand side, we see we have a greatest common factor for the coefficients of 6, and then both of these also have two x's in common. So that's what we're going to factor out. And then that would leave x squared, because 6x squared times x squared would give us 6x to the 4th. And 6 times what would give us negative 54? That would be a minus 9. 9 times 6 is 54. And we don't need any more x's. So we close up and then say equals 0. Now, if you notice, or you should notice, that x squared minus 9 can be factored further. That is actually the difference of squares. And that factors as x plus 3 times x minus 3. And then we bring down that 6x squared also. Okay, so now we're ready to use the zero product property. Now, the way I presented this to you, we have a times b equals 0. But here I actually have an A times a B times a C, but it works the same way. Basically, we're going to set each of these equal to 0 and solve each one. So here we can divide both sides by 6, which leaves x squared equals 0. So we know the only way that can work is if x equals 0 itself. And then here I subtract 3 from both sides. So there's an answer. Here I add 3 to both sides, and there's another answer. Now, one thing you might want to notice, the degree of the equation is this highest exponent here. That is the degree of the equation. That tells us how many solutions. How many solutions? And later on, we'll see that also tells us the number of x-intercepts. But what I want you to notice here is I have 3 solutions, but I should have 4. But if you notice this x squared, that means we get this same answer twice. In other words, I could rewrite this as x times x equals 0 and then say x equals 0 and x equals 0. It's called a double root. So of course, we don't actually have to list it as an answer twice, but we want to understand that it counts twice when we're thinking of the number of solutions. And that piece might make more sense to you later, but I wanted to bring it up. All right, let's move on down and look at a second example, which is 6x to the 4th equals 3072x. Okay, that's a really big number. So what we're going to do is, again, think about using the zero product property. So I need to get everything on the same side. So the first thing I want to do is subtract that really big number from both sides. So I have this. Now it looks very similar to the one we just did. What we need to do now is factor out what they have in common. 6 again goes into both of them. Now this time if I have x to the fourth and x to the first, I can only pull out x to the first. That's the most they have in common. So when I do that, that leaves x to the third, because remember, when you multiply, you add the exponents. So x to the first times x to the third, we would have 1 plus 3, which is 4. Now, 6 times what will give us 3,072? We're hoping that comes out even. And if you divide that, we do indeed get 512. And we don't need an x because we have one here. And there we go. Now, the next thing we need to look at is how to factor this. So I'm going to come over here to the side and talk to you about that. So we need to factor x cubed minus 512. So in that factoring review section, you may remember something called the difference of cubes. And this is just a formula that you have to learn. And I'm going to show you the way the book would give you the formula is they would say this. If you have a cubed minus b cubed, that would factor according to this pattern or this formula. Okay, now in other words, you have something cubed minus something cubed. Well, we see x is cubed. Can something to the third power give us 512? Well, we can use our calculator, but what we're really looking for is what is the cube root of 512. So we're going to come back to that in just a minute. What I want to do is show you that I use this method. I affectionately call it my box method. And I'll show you why I like it. Okay, so here's what we need to do. I have x cubed minus 512. I need to rewrite it as something cubed minus something cubed. So the first box would have an x in it because x is cubed. But for the second one, you need to think what number times itself 3 times would equal 512, and it comes out to be 8. Now, if you say, well, how in the world is that right? What we do is multiply 8 times 8 times 8. So that gives us 64 times 8, which is 512. Now again, your calculator can help you with that. But once we know what that cube root is, so that's what gets plugged in here, are the cube roots. And now we're ready to plug in. Now here's the problem, or it can be a problem. If you're using A's and B's and you're plugging in X's and 8's, it just gets sort of confusing. So you may like to use this method. I like it because it's visual. You literally just plug in. I'm going to go back to my red pen. If we have our little boxes, we just plug our values into the boxes. So we're going to say an X goes everywhere there's a square box, and an 8 goes everywhere there's a triangle box. And then it's just a matter of removing the boxes and seeing what we have left. So that would be X minus 8. This tells us to square what's in that box, so that's X squared. This tells us to multiply X times 8, well that's 8X. And this tells us to square what's in that box, which is 64. So that's sort of a whole lesson on its own, and if anybody needs to see more of those, I'd be happy to do that. But what we have just done is factor this difference of cubes. So our problem looks like it's getting longer, doesn't it? Okay, now this trinomial that comes from factoring the difference of cubes cannot be factored further. So we've factored all we can at this point. So we're ready to think about our A times B times C equals 0. So that means 6x equals 0, x minus 8 equals 0, x squared plus 8x plus 64 equals 0. All right, so let's solve this one. I get x equals 0. That's one solution. Add 8 to both sides. X equals 8. That's another solution. Now, since this cannot be solved by factoring, we have to use a different method. So hopefully by this point, you have reviewed using the quadratic formula, and that's what we need to do here. So our A is 1, our B is 8, and our C is 64. So we have x equals, let me write this down over here for you in case you don't remember. So given, these are like little side lectures, given a quadratic equation in standard form, and that means everything's on one side equal to 0, you can solve for x by using this formula. All right, another formula that you'll need to learn. Okay, so x equals the opposite of b plus or minus the square root of b squared minus 4ac, all divided by 2a. So x equals negative 8 plus or minus the square root. 8 squared is 64. Now here's where people tend to make a mistake. You can't multiply three numbers together at once. So what we need to do is say negative 4 times 1 is negative 4, and negative 4 times 64, that gives us negative 192. So that's what we're going to write down under our brackets here. And all that is divided by 2 times 1, which is 2. All right. So x equals negative 8 plus or minus the square root 64 minus, I think I actually just put, I don't have a calculator with me, so I'm looking at my notes. Hang on a second. I think I did that part. I wrote the wrong number down, perhaps. Yes, I did. But luckily, with this technology, I can erase it easily. So let me just back up a little bit. I should have just had my calculator with me. Okay, I'm just going to read you this part. Just like if I was really in class, sometimes we make mistakes. So b squared minus 4ac is what we had there. And then 64 minus 192, that's actually the one I needed to get rid of. And if you're calculating it, you're probably going, what is she doing? She put the wrong number down. Okay, so that should be 250 minus 256. Let's see, I'm going to double check that. So 64 times 4. Yep, 256. Okay, so now 64 minus 256, that gives us our negative 192. Now we're on the right track. And after all that, you think, oh, we must be done. But no, because now we have to simplify what we have under that radical. So I'm going to move it down a little bit so we can see it better. So the first thing you have to notice is that this number under the radical is imaginary. And the reason we know that is because it's a negative under the radical. So you just need to be sure that you notice that. And then we need to simplify it by factoring out the square root of -1. That's the first step, because that is what I equals. I equals the square root of -1. Something else to remember. So we want to factor out the square root of -1. That's the imaginary part. And then we need to think of the biggest perfect square factor that goes into 192. So again, you're going to want to have a calculator here. The perfect squares are going to be numbers that have square roots that come out evenly, like 4, and then 3 squared is 9, 4 squared is 16, 5 squared is 25, 6 squared is 36, and we just keep on going. So if you have a calculator, you would just say 192 divided by 4. Well, that goes, but there's probably one bigger. So you want to keep going until you convince yourself you found the largest perfect square factor, and in this case, it's going to be 64. So I'm going to keep on breaking this down. So I have I times the square root of 64 times the square root of 3, and then the square root of 64 is 8, and the square root of 3 cannot be simplified, so I have 8i times the square root of 3. So when I rewrote this, I got interrupted and didn't write down the 2, but make sure you put the 2 on the bottom. And now I'm ready to simplify that second piece and say plus or minus 8i times the square root of 3, all divided by 2. Finally, now I can simplify that fraction. I have to divide 2 into both of those. So divide into both. So x equals -4 plus or minus 4i square root of 3. So those are 2 solutions because of the plus or minus. So we'll just throw those in with the other 2, and those are our solutions. And notice we do have 4 because this is 2 solutions. And those are 2. And so from our equation with the degree of 4, we expected 4 solutions. So that was like the longest problem I've seen in a long time. So I assume since the person sent that problem, they saw it somewhere in the course materials, but I don't know where that would have been. But that's kind of good because it covered a lot of the information that you are responsible for. So keep the questions coming, and I'll talk to you soon.